Hi Tim.
Hello, Pallab.
Hi, so you're obviously training for zero G. How similar is it, as far as you know, to the real thing?
Well, here in the neutral buoyancy facility, it's as good as we can get for long periods of time on Earth. What the water gives us is neutral buoyancy, which means we can orientate our bodies and anything we're carrying in any direction, and that feels a little bit like weightlessness. Obviously it's not zero gravity, we have the viscosity of water, and so we have to bear that in mind when we're manoeuvring. But it's great for training for long periods of time.
And do you have to do certain exercises in models of the laboratories you're working in with those huge gloves you're wearing?
That's right. We will go down into the pool, the Columbus laboratory, and an airlock as well, and things like foot plates, and we can practice working with these cumbersome gloves. If you can imagine in a pressurized spacesuit, it's very hard just to bend your fingers with the pressure inside the glove. And we have to manipulate things such as these tethers in order to perform tasks and operate tools, so we can practice working outside the space station using this equipment.
And do you hope to get a spacewalk while you're there?
I certainly hope to. I think every astronaut hopes to. It's too early to tell whether there'll be one during my increment, but all astronauts are trained for spacewalks. As we've seen recently, you never know when something might fail and need replacing on board the space station. So it's important for all astronauts to be able to go outside to do a spacewalk and keep the space station running.
Now you've got to do these exercises for hours at a time sometimes, is that so?
That's right. Normally, once you've gone to the effort of preparing for a spacewalk, it makes sense to do as much as possible. And the spacesuit can keep you alive for about 8 hours outside the space station. And so we try and maximize that time to get as many tasks done as possible. So an 8-hour spacewalk would be a long one, but normally anywhere between 6 to 8 hours.
Tim, thank you very much.
You're welcome. Pleasure talking to you.
Just stay there looking at the screen for a minute.
Tim, we're just taking a few editing shots just now.
Sure, if you want me to do anything, then just let me know.
And so what are you able to do?
If they could get the same shot they had
grab some tools. I don't know if you saw that when I was doing my check of the mini workstation. But I can practice, grabbing some tools, manipulating them.
Okay, that'd be great.
Okay.
And if you could just give a commentary about what you're doing, that would be great as well.
Sure, this is a mini workstation end effector, and it retracts, and so what it's good for is latching onto the space station, and then you can retract it, lock it in place, and that helps to keep you close to anything that you're working on. It's very important in zero gravity to stabilize your body position. As you can imagine, if you put any force into your body or into a tool that you're working on, you're going to spin in the opposite direction. So we use sort of tethers like this to stabilize our work position. It's also extremely important that we don't become detached from the space station. Something like this, which is our local tether, we will attach it to a handrail, and that will prevent us from floating away from the space station. Clearly, an extremely important piece of equipment. Now, if the worst happened and an asteroid did become completely detached from the space station, we have these safety tethers. Now, the safety tether would be anchored somewhere, say for example, back at the airlock.
You've also got special boots, haven't you?
Yeah. So I was just saying, the safety tether, you would anchor this, for example, somewhere on the space station, and then as the astronaut moves, this safety tether provides a connection to the space station, and should you become detached from the space station, it's another form of protection.
I see a reel there. How long is it? How long is that tether?
We have two types. One of them is 55 feet and one of them is 85 feet. You can also string them together in a tethered pack. And that enables the astronauts to be able to reach the farthest parts of the space station. And even then, we've got the robotic arm. So sometimes, if you've got hard to reach places, the astronauts might have to attach themselves to a foot plate at the end of the robotic arm and use the robotic arm to position the astronaut wherever he needs to be.
Well, Tim, that's fantastic. Thank you so much for sparing the morning. We've found it fascinating, and our viewers and listeners will too. So thank you very much indeed, and good luck.
Thank you very much.
Bye.